Hello, everybody. Welcome to our panel. This is, first I'd like to talk about our company. So you see that we're branded EMD Electronics. We're a leading supplier of integrated material solutions for the electronics industry. Key thing is we've got the broadest portfolios of materials and material-related solutions for the semiconductor industry. And we're also seeing that there's a convergence between our display or optronics area and our semiconductor area. So we're really offering a detailed portfolio of solutions. We're actually part of a much bigger company. So you can see the nice map. The part in light blue is where we are branded as EMD Electronics. The rest of the world, we're Merck KGaA, Darmstadt, Germany. So this is how we operate. And we're three core business areas. So we have life science, healthcare, and electronics. So it's a very diverse offering. But what you're hearing today comes from the electronics area. But together as the one company, we have the tagline, sparking discovery, elevating humanity. You can see 358 years old company, but we're also nice and vibrant. You can see by the colors and everything. So we're keeping everything alive. We're really pushing for the innovation. Yeah? To do that, we have 63,000 employees worldwide. Yeah? And we invest back into R&D. You can see the 2.3 out of the 21 billion. So we see R&D investment as a key part for us to keep relevant for the future. So we've got a panel now on one of those innovation topics that I'd like to talk about. From optics to immersion, how we're building the foundations for the next big thing in AR. I will moderate this session as we go through. And then we have a panel, a very esteemed panel with Ed Tang, Barry Silverstein, and Ronny Timmreck. What I'll do is I'll pass over the mics and they can give a very short introduction about them. We'll get that out of the way, and then we're going to discuss about the topics for what we would like to do. So, I mean, Ed, maybe if we just go down the line, and let me come and join you and sit down.
Thanks, Richard. So my name is Ed Tang. I work at a company called Avegant. We build light engines, and what light engines are the tiny projectors that go into AR glasses. It's exciting to see a few AR glasses out in the audience. And these tiny projectors are what create the image that's projected into your eye and really power the visual experience inside these AR glasses.
Hi, my name is Barry Silverstein. Most of the people know me from Meta, where I spent 8 years leading the R&D team in optics and display, and the last year spending time working towards commercializing a lot of those technologies. I'm currently at the University of Rochester, leading the Center for Extended Reality, and I'm also the chairperson under the AR Alliance, leading laser display for AR.
Yes, I'm Ronny. I'm the CEO of vitrealab. We are a company also, as Ed is working on the light engine part of the AR glasses, but we are using laser light for illumination, and that's our core technology. So we have a photonic integrated circuit technology developed that is able to manipulate laser beams in a way that they are enabled to illuminate an LCOS panel, and this way we can achieve high brightnesses, high efficiencies for the light engines.
It's brilliant. So what hopefully you can pick up there, we've got a lot of knowledge about what's needed on the hardware side. Our expertise is on the materials, so this is where we come in. So we're going to now have a discussion about what's needed to drive the next big thing, what that is, how all of that needs to come together. And it's not just a case of, Ed, please make a better light engine, or Barry would say, okay, this is how we got to integrate everything. Please, now you go and make all your materials work better for this, or whatever, right? So it's a case of bringing it all together, and that's what we want to have a bit of a discussion. So I'm putting it out to the panel. I mean, this year we've seen a lot of innovation enabling AR glasses, right? And I think some of the products that have come are pretty impressive. and you'll see them around the show and everything. But it's not the final thing. It's not that big thing just yet. So we had a bit of a discussion. I'd like to keep it a friendly chat on what's needed to make it that big thing. Where do we need to go?
I think I had a question for Barry, perhaps. Before we dive into the details of the hardware and all the geeky stuff, I think it'd be great for you to talk about what makes AR platforms so exciting. Like, why are we chasing these AR glasses? What are people going to do with them? As consumers, why is this an important platform? I think Barry has a ton of experience developing these platforms.
Yeah, that's a very interesting question. So in the near future, and I think we're already seeing this, AI is going to be our guide for our day. AR glasses themselves are representative of our world as much as you can get. In terms of technology, our head is basically where our senses combine. Our bodies are equipped to move our head around, and most of our senses are acquired from the head region. If you combine sensing from your glasses along with AI, add in audio, and of course display where most information is fed, essentially you'll be able to have all of our human knowledge available to us whenever we want it, whenever we need it. And this will be a profound shift in the way that we work with computers. So pulling things out of your pocket will no longer be reasonable, because now you can have a display on your head and an interface that is seamless to the human form. What you can do with that is, of course, everything that you can do today, but more, because with the contextual awareness fed to the AI, you'll be able to create an assistant for your daily actions, for the things that you're trying to do, and also a monitor for your well-being, which is something that you can't do very easily any other way.
Yeah, I've seen these incredible demos because unlike the phone that's in your pocket, the glasses that are on your face, they see what you see.
That's
and because
right.
it sees what you see, when you feed that into an AI assistant, it's like having superhuman knowledge about everything that's around you.
I call it a second brain.
Second brain.
So essentially the AI becomes a second brain for you that you can capitalize on and train it to be what you need. So instead of AI being this fearful thing that will take over our existence, it can be, with AR, essentially this supplements our existence and provides us additional capabilities that we didn't have before. So it will be the greatest tool that we've developed for humans.
So for us to have that realized, what's some of the gaps today, and where do we need to go? I mean, I don't know, Barry, you want to pick up, or Ed, or Ronny, right? You can all have a say.
I don't know where to start. There's so many challenges, right? First, I'll say, the human head is not about to change. We all know what a comfortable pair of glasses feels like. They have to look good, they have to feel good, you have to wear them all day. If they're too heavy or too bulky where you look ridiculous, we're just not going to see adoption. So what does that mean for AR glasses? That means that we need to build a pair of glasses that only look like glasses, but they need to feel like glasses. And we translate that into engineering specs. What that means is 50 grams on your head, max. We need to be below 50 grams. That's the industry accepted weight for having all day wearability. When something weighs more than that, you get tired, you get heavy, you get pain. And what 50 grams also introduces is a thermal dissipation limit, and additionally a battery limit. So when we think about things that are low power, all the technology that needs to go into these glasses, displays, processors, cameras, wireless, all of that added together, we typically cannot exceed more than 1 watt of power. So it's insane constraint that we have to hit. And plus all the technology to try to cram in there is insane. So starting from optics, which we work in light engines, to illumination sources like laser-based stuff that Ronny is working on, and how things are integrated and to make things really compact and light and fashionable is extremely difficult. Maybe you guys can add more detail.
Yeah, let me add to that. So you'll never be small enough, you'll never be light enough, you'll never be efficient enough, right? So, because there'll be the next thing that you want to add into the glasses to make it more feature rich. And so what you're going to see and what you're beginning to see is what is able to be put into 50 grams or less. And as the technology matures, more features will be added, which adds more capability with the applications that come along with it. The real breakthroughs will occur once you can get to 50 grams or less binocular vision in a form factor that is socially acceptable where you can see the eyes. And I'd also say that you need to have some level of privacy from the display reaching to the outside world. And once that hits, where it's basically a regular pair of glasses, but now with a stereoscopic display in it, you have something that can really trigger the market moving forward. After that, you're going to need eye tracking. Okay, so eye tracking is necessary because to really understand a user's intent, you need to have a degree or less of resolution of where the eye is looking. Otherwise you lose the absoluteness of the intent, and the AI will struggle between the two things that you might be on crossing those lines, and so that will really enable quite a bit.
So when I look at these pair of glasses, the power on we're consuming these glasses, I would say roughly about half of them are in displays, and the other half are in sensors, compute, things like that. Now, on the display side, there's incredible challenges because they need to make them really small, but because they're fundamentally transparent displays, they also need to be super bright. Because when you go outside, it's not like you have a screen with a black background. You're trying to overpower daylight brightness. So the combination of super low power and high brightness is like we're fighting physics here. And maybe I think Ronny could try
exactly. And
to
I think this is, for me, this is one of the main challenges we currently have. We need photons. So we are limited in photons to the eye, and the efficiency of the light source, of the light engine itself, and of the overall optical system, I think this is the major challenge we currently have. If we have a look to the products on the market, let's have a look to the Meta Ray-Ban display. I mean, this is a really super nice product, but still the field of view is very small. It's in 20 degrees. The brightness is not super high, so I think you cannot really use it outdoors in sunlight. But it's a really very nice first step. But you can see there is a lot of work to be done on the efficiency. I think we have to increase optical efficiency by a factor of at least 5 to reach a level where we have a decent field of view. And I'm not speaking of a field of view of, let's say, something like 70 degrees. For that, I think we need probably a factor of 10 in efficiency. Of course, we can also save efficiency with a waveguide. This is also another topic. Today's waveguides have an efficiency of 1%. Of course, the geometric ones probably 5%, which is better. I think, by the way, this is the reason Meta has chosen the geometric one, because of efficiency. But efficiency is key, and laser, coming to this topic, laser is, of course, one of the key elements that can solve it, because the optical efficiency of a laser-based system is much higher than of an LED-based system.
So if we're looking at it, we're needing to increase the brightness, right? We need to make it lighter. That's the other. Some challenge is bringing both of those things together. More efficient, so it's no use just having a very bright light that consumes the battery even quicker, because the aim is to wear them all the time, right? So looking at those things, and this is where we were discussing before, it's really co-optimizing together between what the materials need to do, what the components need to do, what the system, the fully integrated piece needs to do. So
yeah. So interestingly, the field of view matters as well. So the size of your screen matters. Okay, what you can do with a larger screen is much more. People will always choose a larger screen if it doesn't negatively affect everything else. If you can carry it in your pocket, and it's fine. But of course, as you go up into a larger screen size, all of these attributes become more and more difficult, right? So what you're going to see is a growth in field of view, and going to binocular, but it gets capped. It gets capped at with a particular technology, because you can only shrink things so far, which is one of the reasons why laser has a potential. Because if you understand lasers, they emit from a very small area, and they emit it at a very small angle, and they emit a very narrow band, and it's polarized light, which gives you the best opportunity for the most efficient systems you could possibly have, the highest transmission as well. Now, going to a wide field of view, immersive display is important, because what you'd like to have is an overlay of the digital world onto the real world. Right now, we're basically building messaging systems, okay? So it's content, but it isn't really overlaid onto the real world. And you can't overlay it onto the real world because you have a fixed focal plane. And so there is only one place that'll be in focus at the same time. So if my plane is here, of my image plane here, this is great. I can see this bottle and my display at the same plane, but you move it out or you move it in, all of a sudden there's a disconnect, and that causes problems. But until we achieve that, okay, we don't really have true AR, okay? And in order to achieve that, fundamentally, I think you're going to end up going towards laser display. But the question is, how long will it take to get there? So what vitrealab is doing is a start in that direction. Okay, and what Ed is doing is spinning the wheel, trying to get glasses moving into the pipeline and getting some volume going, and eventually this line and this curve will go. And we'll achieve the ultimate glasses, which we'd like to have, which is wide field of view, glasses that accommodate, that are highly transparent. The question is, how long will all that take? But what I will say, for Richard's sake, is that this requires new materials. There is no doubt in it, because the current materials are not good enough.
And we're actively trying to address that.
Yes,
succeeding to address. So some of the areas we work on, of course, are increasing the refractive index for the field of view, and the lightweight side, and the eye tracking piece and others as well. Everything is normally, we want high refractive index, apart from then suddenly you want very low refractive index when you want it as an optical isolation layer. So these are all the areas we're working on. Whatever's typical just isn't right, all right? So you go to the extremes, and that keeps our guys very busy. But again, I'd like to come back. It's not just us doing the materials, they've got to fit all together, and this is the key thing. So one other thing that typically as a company we don't highlight too much, but I think, Barry, when you're old company, you hammer it down a lot, is cost, right? So looking at the price point of where it goes. And one of the things that we're looking at is a scalability type approach. So not only do we get it right in terms of making the materials to fit in the devices and everything else, but it's got to be able to be produced high volume manufacturing. And that's something also that we're very conscious of. I mean, I think we all are. I want to have a little bit of a shameless plug for our PVH demo, which is over there, which uses inkjet printing to put down the gratings. And here, along with Avegant for the light engine and putting it into the frames and everything else for their demo frames, it's a technology concept. They're not the glasses you're going to buy, but it's the technology concept. But inkjet printing is one of the key things that I think will help drive us in the right direction for the price points.
Yeah, absolutely. Just to add to the manufacturability, that there's a lot of really interesting technology, a lot of great research, but in order to get these products into your hands in the next year or two, these technologies need to be mature and scalable and low cost. And scalability is a big problem right now in the industry, especially on technologies such as waveguides. right? We see a lot of interesting waveguide technologies out there, and everyone is trying to get them mature enough so they can scale them to manufacturing and make not just thousands of them, but how do we get to millions of waveguides? And everyone is trying to develop that capability right now so we can get the cost down so that consumers can actually go out and buy them for hundreds of dollars and not thousands of dollars. And we do the same thing on the light engine stuff. So we've been building these really advanced, super tiny light engines, but they're not research projects. Like we have fully automated manufacturing lines running in Asia with supply chains, building these things at starting to get to very high volumes for our customers.
Yeah, perfect example for those of you who are Meta watchers. So you may note that Meta canceled its scaling of the Ray-Ban display in Europe and Asia because the demand is so high in the United States that they can't keep up with the current demand. And creating a new factory for a geometric waveguide, for example, is not inexpensive and not fast. So this is one of the reasons why Meta had developed PVH, and Merck has picked up the charge on this, is because a scalable technology is inkjet applied to a flat glass plate with an exposure process. Doesn't get much more manufacturable than that. That's like how film was made back when, right? So this is the kind of thing that you can produce a factory that can produce millions very quickly, and it is easy to scale and create a new factory because inkjet heads are known and easily replicatable. So it's not brand new. It is a new application with new materials. That enables that, so scalability. So my hope is that PVH will take off as a really low cost method of making a high quality waveguide, highly efficient for polarized sources like Ed's engine LCOS and like vitrealab's engine of laser, which is another advantage.
Yeah, and I would say that's on the waveguide manufacturing side, big challenges today, and these type of technologies to get to lower cost, scalable waveguides is what the products need, and it's what we need too as engine makers. We make these light engines to power these waveguides, and we want to make sure you guys can make a ton of waveguides so we can put our engines on them. And even from the display standpoint, there's so many different display technologies out there. You hear about things like micro LED has a lot of hype right now, but it's very difficult to scale, especially in color. And so most of the companies who want to ship color products, such as the Meta display product, today uses LCOS. And we primarily focus on LCOS technologies because of its scalability. But how can we continue to make LCOS even smaller and even lighter and even higher performance, yet still maintain the scalability? And this is where technologies like what Ronny is working on.
I mean, before we pass to Ronny, though, I mean, you're announced now your thinner or your better LCOS, so maybe a little shameless plug for you as well.
Yeah, we'll go into more details in a few weeks, but at SPIE, we announced a 0.7 cc light engine. So think about a sugar cube, cut it into thirds, and we have a light engine that's 1/3 the size of a sugar cube, and we've doubled the efficiency. So it's half the size, half the weight, half the power, and it's even better integrated with waveguides. So one of the things we've done, we talk about co-optimization, is we've done things like shrink the pupil size. And what that allows the waveguide makers to do is to make thinner and lighter waveguides with higher efficiency. And the other thing that we've done with our new engines is our engines now don't project straight out. They project at this funny angle. And the reason why we project at an off-axis angle is we can eliminate the forward glow, the leakage that you see off of waveguides. If you've ever seen people wear AR glasses and they have these, what we call Terminator eyes, they're just glowing. So now we can really mitigate that and control that. So they really just look more like regular glasses, right? It's not just engineering and technical challenges, but it's also fashion and social acceptability.
I mean, Ronny, would you like to pick up?
So what I want to mention is that we should also be realistic about the timeline of those new concepts, and of course we have that great vision of this immersive view, but the next steps will not be that immersive view. So the next step will be a stepwise development of what we've seen already. It will be probably a bit of increase in the field of view. it will be a bit brighter, a bit more functionality. Battery lifetime is, I think, a big issue, which is still a point, but it will not be a huge step, but we will see probably in 2 years a product that is definitely better, but not yet that kind of vision which we are envisioning. And the PVH will also take a bit time. That's why we should be realistic. So 2 years is probably a time where we will not see the super wide field of view and immersive views.
No, you may see it, but it won't be in volume. So which is the point, right? So
demonstrators, yeah.
So demonstrators, maybe even low volume products at best. But you make a really good point, and this is the thing that we need to pay attention to. There has to be some level of evolution in product development. You learn more. You learn what the customer needs are, and you learn how to get your technology into the market. I mean, Ed, you started out with more simple engine designs, and now your next step is better. And then you'll scale your production as that goes, because you have to teach everybody to walk before they run. And this is the same principle with the laser work. It'll go down the same path. So brightness and efficiency is going to be key, and nobody knows how much brightness we really need for the product, especially with some dimming technologies that come in place. But you should note that the Ray-Ban Metas were shipped with 5,000 nits. That's really hard to keep up with as you go to a binocular in the power demand, a binocular and a larger field of view. Really hard to keep up, but if that's what's necessary, it's going to be a real big challenge. So in the laser display AR laser display for AR working group, we're essentially going to be feeding the entire path from the simplest laser displays to more complex laser displays as time goes along, and nurture this path forward. I think that micro LED will have scaling problems, and it'll be interesting to see how this plays out. But eventually, micro LED will have efficiency problems because the efficiency drops as the pixel size shrinks. And it has solutions, and vitrealab has solutions, and so it'll be really interesting to see how that plays out over the next few years.
Definitely. So I mean, if we're looking, we had a panel last CES, got a panel this CES. Things have moved on, right? We see a lot of progress. I think everyone was talking, well, there's AI glasses and they might have displays when we were in the last time. This year, that's realized, right? We see that. And it's the smaller field of view, and the weight is maybe a little heavier than would be ideally wanted, and things like this. The way that we're really working all together on this to do it in a cooperative way across, bringing everything together, as you were saying, Ed. Your design of the waveguide of the light engine allows a thinner waveguide that'll help on the weight and things. Just as the example here, right? And that's still the same message. I think. I mean, to me, that's the takeaway from this. I don't know what if you were to see it differently, or you could put it better.
I think, given the extreme constraints that we have, we want to make these glasses look small and light. But as you keep adding functions to it, it's so challenging to achieve the specs that we need that it's always going to be a game of compromise. And every single component, literally every component of these glasses, will impact something else in the glasses. So we all need to work very closely together, not just on the optics side, but also on the mechanical frames, the fashion, the ID, the industrial design. We all need to work super closely together to find the right co-optimized solution to get the best kind of net outcome.
Yeah. I like to describe this as the hardest integration challenge known to mankind. So look at the shape of a pair of glasses. Look at what area you have to work with around the frames. Well, they can't be too thick. The side arms, they can't be too thick or too heavy. You can't have misbalance. They have to work on faces that are flat or pronounced, and they have to look fashionable. And now you have all of the technologies that are in a cell phone and then some, and it's got to work all day, and you know, it makes an iPhone look easy, and that's why it's going to take some time, but it's also why it's the most interesting area to work in.
Absolutely. I mean, Ronny, last comments as well?
The optical system is such a complicated system, so it was never ever built before in this kind of form factor, you know. I mean, all of you know beamers that are kind of large, but we do the same in a form factor of a third of a sugar cube. That's so fancy new, that's why it took so long. I think the expectations were much higher, and you were asking what is the difference from last year to this year. I think we have hit a lot of the expectations over that year, but I think the expectations have been that 5 years ago AR should have been there where it is today, and the reason is the complexity of those technologies, definitely. As Eddie already mentioned, that putting all the things together in a way that it works together, that's a challenge. Can you give you a tiny little example? But laser illumination, of course, realizing a light engine with a laser sounds like, yeah, it's the output is the same as an LED. It isn't. You have to find the right waveguide. You need a different waveguide. You need to adapt it. So there are so many challenges that all of that takes probably half a year to realize it, and in the end it adds up, and that's why we need such a long time to realize, yeah, at least a part of the vision.
I'd like to make a plug for the AR Alliance for this. So one of the reasons that it takes so long is because you have to create the interactions between many companies, right? There's a company that makes sensors, there's a company that makes waveguides, there's a company that makes lasers, another company makes engines or parts of an engine. There's the audio, there's the battery, there's all these. So by having an alliance where some level of standardization, at least for the demonstration purposes, so that you can prove that the technology works as a whole, is necessary. And so the laser display group is intentionally built to try to establish some level of requirements for interoperability, not for the final product, because that gets tailored by the end customer, the end integrator, but for the intermediaries, for these demonstrations to have proof of capability is so important. And so far it's been siloed, so that nobody knows what everyone else is doing or who to talk to. And what they should make is one company will say one interface and another company will say another interface. So there's 10 different waveguides that have to be made, or 10 different lasers that have to be made, or 10 different LCOSs that have to be made. That's extremely expensive and inefficient. And so by doing some level of standardization, we can speed this process up and get these new things to market much faster.
Yeah, I fully agree. The concept of bringing everybody together and harmonizing is what we need. I think we're about on time, but if there's last comments, please.
I want to mention one important thing. What we also need to wait for is a real feedback from the customer. So we are talking on the technological level, but of course we have seen that the Meta Ray-Ban display is selling very well, but I mean the capacity is also quite low. So I think we do not have yet seen a real feedback what the customer really needs, and I think our vision is clear, but we do not know how that resonates with the broad customers.
Yeah, only Meta has the feedback so far. So but more is going to be coming, and it'll be very pronounced over the next year or two.
Yeah, I see a lot of momentum. It's giving me the feeling it's all moving in the right direction, and I'm ever the optimist. I expect some more exponential increase. Yes, if you draw your straight line, Ronny, right from now, 5 years ago to now to 10 years later or something, it's not going to be a straight line. It's going to be down. It's probably ups and downs, right? But then it should take off. So.
It should be all ups. Just how fast the ups?
Exactly. It should be going up. Yeah. So, and on that note, I think we would like to close and thank you all for attending. Thank you very much. Thank you to the panel. Thank you.